So, next question. Ethene will react with steam to form ethanol. Propene will react with steam to form two isomers, both of which are alcohols. Suggest the structure of these alcohols. Now, I've included the structures for you, and I wanted you to understand why I put those structures there. All right? Now, prop, P-R-O-P, tells us that we are dealing with 3 carbons. 1 carbon, 2 carbon, 3 carbon. If you check here, 1 carbon, 2 carbon, 3 carbon. And they tell you that they are isomers. Now, isomers are atoms of the same element, right, that form a particular compound. They have the same molecular formula, meaning to say they have the same number of carbons, same number of hydrogens, same number of oxygens. However, they have a different structural arrangement. So if you look in the first structure, the OH group is on the first carbon, but in the second structure, the OH group is on the carbon in the center, right? The OH group is on the carbon in the center, right? So that is example of isomers. Next question. Esters are organic chemicals noted for their characteristic smells. Ethanoic acid and methanol would react to form an ester. Name the catalyst needed to form an ester from ethanoic acid and methanol. Right? This is one that you have to know, right? You need to know that the answer to this is sulfuric acid. Sulfuric acid, concentrated sulfuric acid, is needed to form an ester from an acid plus an alcohol, right? So an acid plus an alcohol will require a catalyst, concentrated sulfuric acid, right? All the time, every time an acid reacts with an alcohol, if you want to form an ester, you must have concentrated sulfuric acid for that to take place. Right? Name the ester form when ethanoic acid reacts with methanol. All right, so what we do, we take the prefix of the alcohol, which is meth, and we add YL to it. So it becomes methyl. Then we take the prefix of the acid, et, we remove OIC, and we add OATE to it. So we end up with methyl, and instead of ethanoic, it becomes ethanoate. So the answer would be methyl ethanoate, right? We take the prefix of both the acid and the alcohol. For the alcohol, we add YL to it, and then to the acid, we add OATE to it. So it becomes methyl ethanoate. Right? When we come across esters and alcohols, we'll come across this again, right? But I saw the question there and I decided just to put it in so that you just have exposure to this type of question. Next, they say, draw the structure of the ester formed when ethanoic acid reacts with methanol and show all bonds, right? This here, this bond right here, C double bond O, is characteristic of esters. Right? Anytime you're looking to see if an ester is present, you look for C double bond O bonded to oxygen. Right? When you see that C double bond O, you know that an ester is present. If it have an H here, then you know an acid is present. But if there is no H, then you know an ester is present. Right? So that is the characteristic structure. Next question. Alkanes and alkenes are both series of hydrocarbons. They say explain the term hydrocarbon. A hydrocarbon is simply a compound which contains carbons and hydrogen alone, right? They contain carbon and hydrogen alone and nothing else. A hydrocarbon, a compound which contains carbons and hydrogens. That's all there is to it. Next question. What is the difference between these two series of hydrocarbons? So they're asking you, what is the difference between an alkene and an alkene? Don't overthink it, just think simple. Alkenes have single bonds. Alkenes have the presence of a double bond between the carbon. Alkenes are saturated. Alkenes are unsaturated. Alkanes have the general formula CnH2n plus 2. Alkenes have the general formula CnH2n. Right? If you're looking to differentiate between alkanes and alkenes, that's it right there laid out for you. Next question. Alkenes and similar alkenes are made from long chain alkenes by cracking. Complete the following equation for the cracking of the alkane C20H42. Now I want you to watch something here and for you to understand why I came up with the answer I did, right? This is 20 carbons. On the next side, I have 4 2s are 8 carbons here. And I have 2 2s are 4 carbons here. So in total, I have 8 plus 4 is 12 carbons I have already used up out of 20. So I ask myself, 12 and how much will make 20? And the answer is 8. So therefore, whatever carbon I'm putting here should be C8H. 8 2s are 16 plus 2, H18. So I have 1 alkene, 2 alkenes, and an alkane being formed when this undergoes catalytic cracking. All right. Okay, so next question. Alkenes such as butene and ethene are more reactive than alkanes. Alkenes are used in the petrochemical industry to make a range of products, which includes polymers and alcohols. Dibromoethane is used as a pesticide. Complete the equation for its preparation from ethene. All right, so I have the alkene molecule plus bromine to give me some product. All right, so, all right, sorry about that. I needed to tell the dog stay quiet. All right, in dibromoethane is used as a pesticide. Complete the equation for its preparation from ethene. So in essence, we have bromine reacting with an alkene. So what's going to happen? Bromine, which is Br, bonded to Br. Bromine is going to attack one carbon, and the next bromine is going to attack the next carbon. So I'm going to have this double bond here splitting, and bromine is going to be added across the double bond. That's simply what's going to happen. Which leaves us with this. So we end up with bromine added across the double bond, and that is what is responsible for the bromine color moving from a orange brown color to colorless. All right, so what is that saying for us? What is that telling us? That is simply telling us this, that the bromine atom breaks the carbon-carbon double bond to form a carbon-bromine bond, right? And this type of reaction is referred to as an addition reaction. The addition of bromine to alkene is referred to as bromination. If it was chlorine, it would have been chlorination. If it was iodine, you would, I think you're beginning to get the concept by now. Next question. The structural formula of a polyalkene is given below. So they show you the structure. You have CCH3H, CCH3H. Deduce the structural formula of its monomer. So this is what they give you, and they ask you to find where it comes from. Now the monomer is supposed to be an alkene. So the alkene of this is the answer. So the alkene is the monomer for the polyalkene. So for example, if I had ethene, ethene is the monomer for polyethene. Propene is the monomer for polypropene. Butene is the monomer for polybutene. Pentene is the polymer for polypentene. Hexene is the polymer for is the monomer for polyhexene, and so on. So in this case, we have 1, 2, 3, 4 carbons. So we are dealing with bute. So I have polybutene. So therefore, the answer is butene is what I need. 1, 2, 3, 4 carbons. H3 is bonded to either end. So if I add it on either side, on the same side or the opposite side, it doesn't matter as long as I have it. All right, so this here is the answer that they're looking for. All right. All right, so we're coming to the end of the questions. I'll have about just one more question after this, I believe. How is butanol made from butene, CH3, CH2, CH double bond CH2? Include an equation in your answer. If we have butanol, how did we make it from butene? Think back. An alkene reacts with steam or water vapor to form an alcohol. So how did we form butanol from butene? Alkene, butene plus water vapor, H2O in its gaseous form, to give you the alcohol, butanol. All right? That's how it was formed. Cracking changes alkanes into alkenes. How could an alkene be converted into an alkene? Include an equation in your answer. If we want to convert an alkene into alkane, we simply react it with hydrogen. If we want to convert an alkene into alkane, we react it with hydrogen. What happens is the double bond in the alkene is broken, and we end up with hydrogen being added across the double bond. When that double bond is broken, hydrogen is added across the double bond. Right? So take, for example, I have C6H12, right, which is my alkene, plus hydrogen to give me C6H14. How so? If I have C6H12, this double bond here is going to be broken, right? This double bond is broken, and I'll be left with just a single bond. So the bond is broken. I'm left with a single bond, one that comes there and there, right? The bond is broken. And hydrogen from H2, hydrogen is added across the double bond. So one hydrogen comes there, and the next hydrogen comes there. It is added across the double bond. Yes, producing the alkane. All right, so next question. The alkenes are unsaturated hydrocarbons. They form a homologous series, the members of which have the same chemical properties. They undergo addition reactions and are easily oxidized. So they just give us information, and they haven't asked us anything as yet. Okay, cool. First part of the question. The following hydrocarbons are isomers. Isomers, they have the same molecular formula, but different structural arrangement. Okay. Part 1. Explain why these two hydrocarbons are isomers. They have the same molecular formula, same number of carbons, same number of hydrogens, but they have different structural formula or different structural arrangement, right? Means to say that the double bond is not in the same place. The carbons are not lined up the same way, but they have the same number of carbons. They both have 5 carbons, and they both have 12 hydrogens. They have the same number of carbons and hydrogens, except the structure or the arrangement of the carbons are not the same. Next part of the question. Give the structural formula of another hydrocarbon which is isomeric with the above hydrocarbons. So you can take this and move the double bond from there to there, or you could move the double bond from there to there. Either way is fine. Or you could take one of these carbons and put it up here or down here if you wanted to. But the easiest thing for you to do is just move the double bond from the end to the middle. So you end up with a structure, something like this. And instead of having the double bond here, the double bond is now over there. Right? And you would have produced an isomer of the structures above. All right, so next thing, this is the last question, last part of the question, all right, before we move on from alkenes. Give the structural formula and name of each of the products of the following addition reactions. So we come back to addition reactions, and it's telling us something. Ethene and bromine, an alkene plus a halogen, I will have a halogenoalkane being formed, right? So the bromine would be added across the ethene. What will that give us? 1, 2, with bromine added across it. And I will end up with 1, 2, dibromo ethane. I end up with the alkane of the alkene. 1, 2, dibromo, right? 1, 2, representing the carbons which the bromine is on to tell us which carbon it is on. 1, the first bromine is on the first carbon. 2, bromine is also on the second carbon. So I end up with 1, 2, dibromo ethene. Right? So the structural formula, C2H4Br2. This is not what they want you to lay out, right? What they want you to do is actually show them carbon bonded to carbon with hydrogens on either side, and you have the bromine bonded to it. So you have Br here, Br there, with hydrogen, 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 right? So this is what they want to see you produce for them, right? And this is the name, dibromoethane. Next, propene and hydrogen. So if I have propene, it means I have 3 carbons. So I'm dealing with an alkene and I add in hydrogen to it. So hydrogen is being added to an alkene, it would produce the alkane. So instead of propene, I would produce the propane. So that will be carbon, carbon, carbon. The double bond is broken and it will just be hydrogens all the way around. Right? And you put in the hydrogens going all the way around, and that would be the structure that they're looking for. The next part of the question, but1 and water. So if I add water to alkene, I am going to get the alcohol. Also, but, I have 4 carbons. So I have 1, 2, 3, 4. Right? Butene, meaning on the first carbon, there's a double bond. Right? And this double bond here is going to be broken. So when the double bond is broken, water is going to be added across the double bond. So I'll have a OH group on one side, and I'll have a H on the next side. So that gives me H2O, and everything else will be hydrogen, 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 hydrogen. So I'll have the formation of butanol. So if butene, alkene plus water, it has the formation of a alcohol. If I have an alkene plus hydrogen, it has the formation of a alkane. And an alkene plus a halogen, I have the formation of a halogenoalkene. All right. Okay. So that brings us to the end of alkenes. Questions, guys? Tell me if this is making sense or if it's confusing or if we're going on the right track so far. Good to go. Give me a thumbs up, a thumbs down. Talk to me. It's good so far. All right, cool, cool. Good so far. All right, nice to know. All right, good. All right, so, well, truth be told, I only have 7 more slides that I want you to go through, but I think 2 of them is a video. All right, and once we get through that, we will call it a day for today. All right, if I'm sending these slides, yes, I can send it for you. Want me to do that as well? No problem. I can do that for you guys. All right, the next thing. So I'm going to play a video for you now. It's on alcohols. Right, hope you're able to hear.
Hello and welcome back everyone to another Simple Science video, and in this video we're going to be looking at the next type of organic compounds, and these are the alcohols. Right, as you can see, a particularly very popular and prominent alcohol may pop up to mind, that is ethanol. We use this in daily life. Okay, and today we're going to be looking at the properties, the reactions, and the ways in which we can synthesize alcohols. Okay. Now, alcohols are distinguished from other molecules and are described as a particular organic compound that has an OH group attached to it. And this OH group, known as the alcohol group, is responsible for the properties and reactions of alcohols. Now, for any other organic compound, we are going to be looking at the general formula of alcohols. Now, very similar to the parent alkanes. The only difference between alcohols and alkanes in their general formula is the existence of an oxygen molecule between 1 or 2 or 3 or any other number of its CH bonds. Okay, so of course, as I said, this is an example of an alcohol molecule with one OH group, but there can be molecules with multiple OH groups. So in this case, this molecule with one OH group would be called an ethanol. If there were 2 OH groups, it would be called an ethanediol. So di and tri and other prefixes to all would be describing the number of alcohol or OH groups attached to the molecule. So here are other examples of alcohol molecules whereby its names depend on the number of carbons in its carbon chain. And of course, like any other organic molecule, there can be branched molecules. In this case, this is a branched alcohol whereby there is a methyl branch, whereby there is a 1 carbon in its branch. And when we look at the way it's named, like in the previous types of molecules, we have 1 carbon in the branch and a main carbon chain of 4 carbons. So the main carbon chain has the suffix name of butanol and the prefix name, which is the name of the branch. So that is the methyl branch attached to a butanol molecule. So this whole branched alcohol will be named methyl butanol. Now let's look at the properties of alcohols. Now, very similar to any other member of the homologous series that follows a particular trend, then melting point and boiling point of an alcohol increases with the chain length, and this is due to a higher level understanding of how atoms behave, known as the van der Waals forces, and this increases the melting and boiling point of an atom depending on its molecular mass. That's just extra knowledge, but in basic understanding, you should know for the IGCSE syllabus that the melting point and boiling point of an alcohol increases with chain length. And due to this OH group, which gives rise to, again, a higher knowledge understanding of something called hydrogen bonding, due to this OH group, solubility in water of alcohols is very high. Okay, so alcohols can mix very well with water compared to alkanes and alkenes. And also due to this OH group, due to this higher level understanding of hydrogen bonding, the boiling point and melting point of alcohols are higher significantly higher than that of alkanes and alkenes. Now let's look at the reactions that alcohols can undergo. So of course, like any other organic compound, you have combustion. Okay, combustion is when a particular organic compound or compound reacts with oxygen to form carbon dioxide and water. And this can be a complete reaction or an incomplete reaction to form carbon dioxide or carbon monoxide or both. Now, the next type of reaction is oxidation. Now, what differs from combustion is the final product. We're not producing carbon dioxide, but we are now producing a different type of organic compound. And in this case, where ethanol reacts with oxygen through a particular means. So in this first case, it is called microbial oxidation, whereby we are using microbes to aid oxidation. We're going to be producing a compound called ethanoic acid. Now, there's a secondary method, or rather, this is a more prominent method in which we can produce ethanoic acid through oxidation, and this is through heating with an oxidizer or catalyst called potassium dichromate in dilute sulfuric acid. Okay, and this is another way in which we can oxidize an alcohol to form an ethanoic acid. Okay, so these are the reactions of alcohols. And of course, there's another reaction that I listed previously called esterification. And this we will look at esterification. This is the reaction between carboxylic acids like ethanoic acid and an alcohol like ethanol. Now let's look at the synthesis of alcohols, in which how we can create alcohols. Of course, in daily life you might encounter this method of synthesis known as fermentation, fermenting. This is when we commonly see as sugar fermenting into alcohol, right? Okay. Now, this method of fermentation is when we ferment glucose, whereby we introduce yeast as a catalyst into glucose at an optimum temperature of 25 to 50 degrees, and glucose reacts to form ethanol and carbon dioxide and energy, whereby energy is stored as ATP. And the synthesis of alcohols can go a different way, and this is a method that we looked previously in the chapter of alkenes, and this is known as hydration. This is when we react water with ethene in the form of steam to form an alcohol. And this reaction takes place at a very high temperature at 300 degrees Celsius and at a pressure of 60 to 70 bars, and with a catalyst of phosphoric acid. Okay, so that is the end of my IGCSE video on alcohols. And I wish you all good luck and best to your revision.
All right, so the next topic that we're going to, and what he did is do an overview of alcohols in detail, right? And I will just summarize everything that he said, and in the next session, we will start going through each section of alcohols and so on, and then do past paper questions about it, right? But just to sum it up, objective 14.9, alcohols, what we know so far, the general formula is CnH2n plus 1 OH. The functional group, the OH bond helps us to identify the presence of an alcohol. So if we have one carbon, we can have methanol, right? That is CH3OH. If we have two carbons, we can have ethanol, which is C2H5OH. If we have three carbons, we can have propanol, which is C3H7OH. If we have four carbons, we can have butanol, C4H9OH, and so on. All right. Now the next thing, how can we get alcohol? By fermentation or by catalytic addition of steam to ethene. right? With fermentation, of course, many of you, I don't know if some of you all know, like your granny or your grandmother, who might be into making wine from fruits and stuff like that. And what they would do is they would leave it to ferment. Now, how does it work? They take enzymes in yeast to break down glucose to ethanol and carbon dioxide, giving out heat. Right? Now, this can be done with substances that contain cellulose, starch, or glucose. That's why you could have different types of fruits because they all have glucose or they all have sugar in it. And the sugar can be broken down to give you the alcohol. Right? The sugar, the carbohydrates can be broken down. How could it be done? By grinding the sauce, for example, grapes, and adding enzymes to it to break down the cellulose and starch into glucose, and then leaving it to ferment, right? And then fractional distillation could then be used to extract ethanol from such a mixture. Right? The other way is catalytic addition. Catalytic meaning in the presence of a catalyst of steam, the ethene. So ethene is obtained by cracking long chain alkenes from oil, right? The ethene reacts with steam reversibly in under high temperature, 570 degrees Celsius, 60 to 70 atmospheres. And the catalyst that is used for this is usually phosphoric acid. Low temperatures would give a better yield of alcohol, but higher temperatures is used because it gives a better reaction rate. So what are the advantages and disadvantages? If we're doing fermentation, renewable sources are being used. There's a good use of waste organic material. On the downside, a lot of material is needed, so big tanks need to be prepared. Fractional distillation is an expensive process. It's a slow process and it's a batch process, right? On the next side, if we're dealing with the ethene, right, it's a fast process. On the plus side, it's a continuous process. You could get pure ethanol and it can be produced in smaller containers. On the downside, the oil that is used as a heat source is non-renewable. So once it is used up, that's the end of it. A lot of energy is required to make steam and get the right conditions. A lot of ethene is unreacted and therefore it has to be recycled. Right? So ethanol burns well in oxygen, giving out plenty of heat as well as carbon dioxide and water. Right? Ethanol is used as a solvent, is also used as a fuel, right? So as a solvent to dissolve things that water cannot dissolve, you could use ethanol as that solvent, right? It evaporates easily. So for example, in your perfume, you can have ethanol in the perfume so that when you spray the perfume on yourself, right, what's going to happen? The alcohol in it is going to evaporate, leaving the scent behind. That's why you can smell nice. Right now, you say, well, what's the difference between the expensive perfume and the cheap perfume? Well, the expensive perfume, they have a greater concentration of the scents inside of it. So therefore, it's able to last for a longer period of time. That's why you pay so much more money for it. Right? But it's the same thing, just one is more diluted than the other. Right? So it's used as solvents. It evaporates easily. It's also used in glues. It's used in printing inks and perfumes. As a fuel, you could add it to, or instead of petrol, you could use it to burn things. All right. So that's to sum it up in a nutshell, what basically alcohol is all about. And that brings us to the end of today's session. All right. So any of you have any questions for me? Right, we have about 3 more minutes before this session comes to an end. I look forward to your questions. Talk to me.